Other questions? Okay, well, let's look at 2.6 then. Infinite limits. In other words, when we're trying to find the limit when x approaches infinity. Okay, so let's look at the first simple situation. If you remember the graph of 1 over x, because remember there are a few graphs that I asked you to remember. Should I refresh your memory on those graphs? Yes, I do, and I insist. Okay, one graph is tangent. I insist to know this graph, for you to know this graph. The other one is very good, or arctangent. I insist that we know tangent inverse. I also insist the graph of 1 over x. Very important. Also e to the x and natural log. We're going to add more, but for now, these 5. Good, so what would you say? The limit of 1 over x when x approaches infinity, or negative infinity. What will that be?
You mean left-hand limit or just negative?
So, the limit of 1 over x as x approaches infinity.
Doesn't exist.
Okay, let's take a look. So, as x approaches infinity, the function values get closer and closer to 0. So this is a very important limit. Very important. As x approaches infinity, the function approaches 0, which means y equals 0 is, for this particular function, is which one? It cannot be vertical. Very good. So here's the next concept. What do you think will happen when I want to determine the limit of this? R is a power and is a number greater than 0, because if it's negative, the whole thing goes to the top. What will this equal to? So let's think. So this is infinity raised to the 3rd power, or infinity raised to the 10th power, or exactly. Exactly. Yes. This is R. R is a number greater than 0. So let's look at the checklist on page 14. 2 things, 29 and 30, but let's start with 30. The limit as x approaches infinity from 1 over x to the r is 0. Of course, r must be a positive number. X approaches negative infinity from 1 over x to the r is still 0. When r is a number greater than 0. So this is what we just quoted a second ago. Now, this is what we just used also a second ago. If the limit of a function as x approaches infinity or negative infinity is a number, then y equals that number is a horizontal asymptote at infinity. So it's a similar definition for negative infinity. So this is what we just did. We said limit of 1 over x as x approaches infinity is 0. Therefore, this is the L in the definition. Therefore, y equals 0 is a horizontal asymptote. The same thing here. For this function, y equals 0 is a horizontal asymptote as well, when the limit is 0. I would like to look at few examples. And these problems are, if you have your book, they are on page 141. And let's start by looking at let's say, let's start by looking at 16 on 141. Limit as x approaches infinity from 1 minus x squared divided by x cubed minus x plus 1. So I'm asked to find this limit. You may remember this from pre-calculus, but I'm not asking you to come up with the answer. Here is the procedure we need to perform, or the steps we have to perform in order to find this limit. So one more time, this is called an infinite limit because x approaches infinity. Not because the answer is infinity. Could be. We'll see in a moment. So every time x approaches infinity, we're thinking of those limits as limits, infinite limits. So I do have here two examples, or limits to infinity if you want. So we're going to work on these two in a minute. So this is on page 2 of the limit document, or limits document. Okay, so first of all, I look at the numerator. Remember, we do not drop the limit operator. We do not drop the limit operator till the very last step. This follows us because it cannot be separated from the function every step of the way unless we replace x by infinity. And that is at the very end. Good. I look at this and I see this is what degree. Right. It's not in descending order. I'm going to put it in descending order. Then I'm going to look at the denominator and I'm going to ask myself what is the degree for the denominator, and I will say, and I will factor out x to the third. And you could say, wait a minute, well, x to the third is not a common factor in those three terms, and I will have to agree, it's not. So we will have to factor out x cubed by force. X cubed times what is x cubed? 1 minus x cubed times what is negative x. X cubed over x squared will be x. Agreed? Plus. Very nice. Yes, that's all I wanted you to say. Let's review this for everyone to see. X to the third times 1 is x to the third. X to the third over x squared is x. X to the third over x cubed is 1. Everyone okay? Of course, I will do the same thing where? Yes. What is the degree in the numerator? 2. So I will factor out negative x squared, just because I don't like negative exponents. You can just factor out x squared if that's what you want. Very good. So what do we have left at the top? Yes? Minus? Very good. Awesome. Thank you. Let's try. Negative x squared times 1 is negative x squared. Negative x squared times negative 1 over x squared is positive 1. Agreed? Now my next question would be, based on what we just discussed 3 minutes ago, when x approaches infinity, where does this go? Yes. Yes. Where does this go? Where does this go? Good. So where does this, just this quantity go? Forget about this for a moment. Exactly. Awesome. Now, I would like to simplify x squared by x squared and x cubed by x squared. Let's see what is left. I have a negative 1. I have an x in the denominator, and this whole thing approaches 1. Can anyone give us the answer now? No more limit operator. Exactly. When x approaches infinity, the answer is Thank you. Which means y equals 0 is a horizontal asymptote. Say that again. From here. That's why I did this first.
Okay.
Very good. Next problem. Let's say 29. Limit as x approaches infinity, x to the fourth minus 3x squared plus x. Is everyone okay with what we just did? Yes, everyone? Any questions? Okay, that's why we look at the second one. Degree at the top, please. I'll factor out x to the fourth. Degree at the bottom, please. I'll factor out x cubed. Please tell me what we have in parentheses. The top is 1 minus
1 over 3 over x squared.
very good, plus
Over cube x.
very good, awesome. The denominator now. Do we understand these fractions? Yes, everyone? Okay, yes? 1 minus,
1 over x squared.
perfect,
2 over x.
very good. Like before, let's analyze what is left in parentheses. Where does this go?
0.
Where does this go?
0.
Perfect. This one, okay. I'll simplify. Where does this go?
1.
And where does x over 1 go when x approaches infinity?
Infinity.
That's it. No horizontal asymptote. Very good. Awesome. Yep. I like to look at one more, but I'm going to make one up.
Okay.
No, no. This is another limit, infinite limit or limit at infinity. Okay? Degree at the top. Good. Degree at the bottom. When you're ready, tell me what to write at the top.
Oh, 1. Right there, right. 2 over x cubed. And minus 1 over x to the 4th.
Perfect. Do we agree?
Yeah.
Everyone? Okay. And the denominator?
1 plus 2 over x over x.
Good. Obviously, I'm going to simplify. Where does this go?
0.
Good. So then the limit is,
3.
which means y equals 3 is, yep. Any questions? Okay, now from the limit handout, I would like you to give me the answer for the first one. 1 minute, and then we'll look at the second one. So we have limit as x approaches infinity from 2x squared minus 5 over x squared minus 2. Say that again. You want me to write it?
No.
No, I meant to copy it because it's too small. Okay, ready? Do we need more time? Do we need more time? Okay, so this is limit. I cannot stress enough, please do not drop the limit operator till the very last step. Okay, so the degree at the top is,
X squared.
and the degree at the bottom is also x squared. So no matter what the degree top and bottom, no matter what they are, you factor out the degree. You don't look at the other side or the top or bottom. So if you're at the numerator and you see, oh, the degree at the bottom is 5, what should I do with the top? It doesn't matter. You have to factor out the degree without looking at the other side, the other part of the problem or function. Yes, I'm ready. Oops. Yes. Good. And the denominator?
1.
Yes.
2 of x.
Very good. I simplify x squared with x squared.
Get 1.
So 1 minus 2 over x squared. So this will go and this will go. Both will go to 0. So this is 2. I have to write that y equals 2 is a horizontal asymptote. Okay? Now I would like to look at the next one. And I would like to work on this together. So limit as x approaches infinity from x minus the square root of x squared minus 4x. Before we look at this, and I would like to go back to these problems for a moment. I jumped ahead without asking you something very important. Here it is. Here, when we calculate the limit, we have to plug in this case, infinity. So where does the numerator go when x approaches infinity? Which of these two terms is strongest? Of course. So if x approaches infinity, x squared approaches infinity, and the minus in front will take us to negative infinity. Agreed?
Yes.
The same thing here. These two terms are too small. When x approaches infinity, this one dictates. This one is the most powerful, right? So going back to our checklist, at the very last page, we have the list of 7 indeterminate cases. So this is the only one we have encountered up until today. This is the other one that we are just looking at, the infinity over infinity. So this is another indeterminate case. As you see, infinity or negative infinity doesn't matter. So infinity over infinity, in this case, turned out to be 0. This one also has infinity over infinity. What did it turn out to be? Infinity. No one can predict what an indeterminate case gives us. Okay? So be very careful. Then this one is also infinity over infinity. These 3 terms are too small. So infinity and infinity. So what did we come up with? 3. So it's 0, it's infinity, it's 3, no one can predict. So this is the second type of indeterminate cases. So this is the ratios. Okay? Then we will encounter, not today, powers, product, not today, and this we will encounter in a minute. Okay? So now we know 2 indeterminate cases. Anything can happen. Good. So finally, of course, here I have the same thing. And look, infinity over infinity turned out to be 2 right now for this particular problem. So no conclusion can be drawn. If it's an indeterminate case, you have to take it slowly, step by step, and see what you come up with. Okay, so now let's see what we have here. When x approaches infinity, this approaches, good. When x approaches infinity, let's just talk about the quantity under the square root. Which of these two terms is the strongest? Which of these two? Right, so this one is too small. Even if it's minus, it's still too small. When I square infinity and then I subtract minus 4 times infinity, this one still dictates. Good. So when I take the square root from infinity, what do I get? True, but there is a minus in front. This, it's an indeterminate case, and we cannot conclude anything. We have to take it step by step. So far we encountered 1, 2, 3 indeterminate cases. These two will come in, these two sets will come in later. Not this chapter. Okay, so then, I know that infinity minus infinity could be anything. What do I do? Let's take a look at the function and draw a conclusion. We've had something similar in which we did what? Let me summarize with you how many types of different limits we looked at. Some of them needed to be factored. Functions need to be factored. Others simplified and factored. Others rationalized. Others, what else we did? That's pretty much it. Simplification, factorization, rationalized. So which do you think will be applied in this case? Please, Tom?
Can't we still take out x or just because it gives us the
No.
limit?
No.
Just because if you multiply, if you have the root of something over x, it still goes to 0.
Not in this case.
In this case, okay.
Yes, please, Nick.
I don't really know what it's called, but you like multiply it by change the minus to a plus. And
That's what I said, rationalize.
Yeah.
Exactly. We have to rationalize. So it's x plus the square root of x squared minus 4x. Awesome. That's all I needed. Very good. So limit as x approaches infinity. I copy the denominator. And please tell me what we have in the numerator so far.
X minus the root of x squared plus 4 squared.
Say it again.
X minus the root of x squared minus 4 squared.
So,
And then
where we can go at it.
so what are we talking about?
let's regroup. This is A minus B. This is A plus B. How do I multiply A minus B times A plus B?
Let's say that x squared.
Yes, A squared. How much is A squared? That's the binomial squared. We're talking about the difference of squares. A minus B times A plus B.
X squared.
So A squared is X squared minus what?
It's just the same. It's just that one.
So what do I write? Tell me what to write. Yes, perfect. But I have to use parentheses. If I say x squared minus 4x, I have to use parentheses. Otherwise, I have to say negative x squared. If I don't use exactly. So the first term squared is this minus the second term squared is this. But I have to put parentheses. Are you with me? Is that clear? Is that clear? Any questions? Okay. So now I distribute and I will get x squared minus x squared plus 4x. Would you agree? X squared minus x squared plus 4x. Good. So the top is 4x. Now the denominator plus x plus. Let's look under the square root. What is the degree of the polynomial under the square root? Very good. I cannot take it out of the square root, but inside the square root, I will do exactly what we just did a few times already. Please tell me what is left in parentheses. Yes? Awesome. Perfect. Thank you. So now I have limit as x approaches infinity. The top will have to wait. And now the denominator, x plus. This is a product. I'm going to separate the radical into a product of two radicals, the square root of x squared times the square root of 1 minus 4 over x. We are allowed to separate a radical when the radicand is a product, like here, x squared times. Now we have to stop for a moment and discuss something very important. How much is the square root of x squared if I don't know what type of x is x? What type of number is x? I cannot write x, because if x is negative 3, this is negative 3, and this is 9. And the square root, exactly. Now this is true. What do we know about the absolute value? From last time and from before, we know that the absolute value of x is either
X,
or.
negative X.
Perfect. It's x if
X is greater than 0.
or equal to 0, and it's negative x if.
It's less than 0.
Very good. Awesome. So now I have to make a decision. Will this quantity, the square root of x squared, will this quantity be replaced by this or by this? And where do I look? What tells me what to replace the square root of x squared by? This or this? What tells me from everything we see here? What? Say it again.
The number under the limit.
Right. Yes. So now this will be replaced by x. What if I had x approaches negative infinity? What would you have replaced this by? Correct. So then I can continue with limit as x approaches infinity, 4x divided by x plus x, the square of 1 minus 4 over x. And like before with all the previous problems, what do you think I am going to do now in the denominator? Say it again.
Plug it in.
No, not yet. I can't. I still have infinity over infinity. This is infinity over infinity. What did we do in all the previous examples that I need to do here? Say it again. Very good, which is? Indeed. Because I have to get rid of the problem. The problem is infinity over infinity. And here's the problem. It goes away. Now, only now I can drop the limit operator. Tell me, where does the limit from the top go? The limit from the top. Perfect. The limit from the bottom. Exactly. Which means the limit is 2. Which means y equals 2 is a horizontal asymptote at infinity only. I have not done anything for negative infinity. I don't know. See, in the previous examples, we never thought that to write y equals 2 a horizontal asymptote at positive infinity, because we did not use the fact that x approaches infinity. But here I did. Where? Right here. Because this had two options. Because x approaches infinity, this was changed into x. Because I used the fact that x approaches infinity, I have to write that y equals 2 is a horizontal asymptote at infinity only. Because we have not looked at the other one. We don't even know if the other one exists. We can, if you want. We can look at the other one. You want to look at the other one? Okay, very good. So let's look at limit x minus the square root of x squared minus 4x as x approaches negative infinity. Perfect. Where does this go? As x approaches negative infinity, x approaches? Very good. Where does this go? So the two, which one of these two is the most powerful? Right, so this one is too small, no matter what. So when I square negative infinity, what type of number do I get? When I take the square root from positive infinity, what do I get? With the minus in front, what do I get? This is not an indeterminate case. Negative infinity minus infinity is negative infinity. You have negative 2, I have negative 2, we have negative 4. Negative infinity minus infinity is negative infinity. There is no horizontal asymptote here. The function values go to negative infinity as x approaches negative infinity. So this was an indeterminate case. This one we had no idea what we would come up with. But this one is not. It's like infinity plus infinity, which is infinity. Negative infinity minus infinity is negative infinity. No horizontal asymptote when x approaches negative infinity. Is that clear? Perfect. Let's look at one more example like this and move on. Let's say 23 on page 141. And I would like you to walk me through this time. This is an easier situation than the previous one, which was more difficult. Ready? Let's check what this is. Which of these two is the most powerful? Good. So when I take x to the 6th to infinity, infinity to the 6th, I get infinity. The square root is, and the denominator? Good. So it's another indeterminate case. I don't know what to expect. Good. I'm back to the denominator. Let's start with the easy one. What do I do to the denominator right away? Very good. And what is left? Awesome. I will do the same thing to the top. Can anyone give us the degree under the square root? Very good. Yes? Perfect. Now I have to ask myself, I can take the square root from x to the 6th, but the answer is the absolute value of x cubed. It all depends on where this is going. And then I know what to write. So I'm going to write this on the side. The square root of x to the 6th is the absolute value of x to the 3rd. Because x to the 3rd could be negative. But since x approaches infinity, what will I replace the square root of x to the 6th by? Do you all agree with x cubed? So 9 minus 1 over x to the 5th, everything over x cubed, 1 plus 1 over x cubed. What do you think we are going to do next? Yes, I'll simplify x cubed with x cubed. And now I'm asking myself, where does this go? Where does this go? 0 and 0. Very good. The square root. Now I can drop the limit operator because I'm getting ready to write the final answer. The top. Very good. The bottom. That's it. So y equals 3 is a horizontal asymptote at infinity only. What will happen if I change the problem into limit as x approaches negative infinity? And I'm going to just copy this. The absolute value of x to the 3rd. Yes. Indeed. The only thing that changes is this negative here, and it will be negative 3. Y equals negative 3 is a horizontal asymptote at negative infinity only. So this function has two horizontal asymptotes. One that is y equals 3 to the infinity, and the other one that is y equals negative 3 at negative infinity. Very good. Any questions? So from these infinite limits, please remember the absolute value, depending on where the x values are going, either to infinity or negative infinity. Please remember this concept. And maybe I should say basically this concept. Okay. Any questions? Here's a problem that we looked at before. However, we're adding more stuff to it. Problem 9 on page 140. Sketch the graph of an example of a function f that satisfies all the given conditions. And there are many. F of 0 is 3. Limit of f of x as x approaches 0 from the left is 4. Limit of f of x as x approaches 0 from the right is 2. Limit of f of x as x approaches negative infinity is negative infinity. Limit of f of x as x approaches 4 from the left is negative infinity. Limit, 2 more. F of x as x approaches 4 from the right is infinity. And the last one, limit of f of x as x approaches infinity is 3. Oops, sorry, you can't see. Should I read them back to you? So f of 0 is 3. Limit of f of x as x approaches 0 from the left is 4. Limit of f of x as x approaches 0 from the right is 2. Limit of f of x as x approaches negative infinity is negative infinity. Limit of f of x as x approaches 4 from the left is negative infinity. Limit of f of x as x approaches 4 from the right is infinity. And limit of f of x as x approaches infinity is 3. Okay. As you remember, in these situations, there is more than one correct answer. What do you think we should do first? Yes, because by looking at this, it's going to be difficult to come up with an example. So organize the information in a table. Let's do just that. Thank you. Okay, so let's put them in one by one. F of 0 is 3. Done. Is this okay so far? Are you with me? Do you need more time? Are you with me, everyone? Okay. Limit of f of x as x approaches 0 from the left is 4. Done. Limit of f of x as x approaches 0 from the right is 2. Done. Are you okay with this? Yes, everyone? Limit of f of x as x approaches negative infinity is negative infinity. As x approaches negative infinity, function values approach negative infinity. Done. Limit of f of x as x approaches 4 from the left. Negative infinity. Done. Limit of f of x as x approaches 4 from the right. Infinity. Done. Limit of f of x as x approaches infinity is 3. Done. I have 2 remarks here. Can anyone tell us what x equals 4 must be? A BA. Can anyone tell us what y equals 3 must be?
A horizontal asymptote at positive.
Exactly. So now once we summarize the information, the whole thing is not difficult. So, ready? Yes? Is this okay, everyone? Any questions? Joe, go ahead, please. Horizontal asymptote because of the infinite limits, right? Okay.
Would it be correct to have parentheses on the ends?
You mean here
No.
or here?
Yeah, down there.
No.
Okay.
Ready? So 0, 3. 1, 2, 3. Full point. 0, 4. Open point. 0, 2. Open point. 1, 2, 3, 4. X equals 4. From 2 down to negative infinity. This was 1, 2, 3. Right here. No, this was 1, 2, 3. Right here. On the right-hand side of 4, infinity down to 3. And this is an example of a function that fulfills all the given conditions. So it said, as x approaches negative infinity, the function values approach negative infinity. The limit on the left of 0 is 4. The function value is 3. The limit on the right-hand side of 0 is 2. The limit on the left-hand side of 4 is negative infinity. The limit on the right-hand side of 4 is positive infinity. And as x approaches infinity, the y values approach 3. Once we clarified this information and we had it organized, it was not difficult. But if you ask me to come up with something by looking at this, I personally cannot. If you can, I'm happy. But I personally cannot make sense of all this. But once I have it summarized, it's very clear what I need to present. Because I wasn't given anything here, obviously the infinities left and right create a vertical asymptote. This was a limit at infinity that we just discussed, approaching 3. So this must be a horizontal asymptote. This is definitely a full point, and these are the limits left and right. Can I say that the limit from either side of 0 exists? No, because the left is 4, the right is 2. Good. Anything else? Other questions here? Okay. I would like to show one example, like, for example, 45, in which we are asked, so this is my page 7, 45 on 141, in which we're asked, find the horizontal and vertical asymptotes of each curve. If you have a graphing device such and such, you can. But what I'm adding here is find the horizontal and vertical asymptotes and present all necessary limits. So here's the function f of x equals x to the third minus x divided by x squared minus 6x plus 5. So we are asked to determine. So any questions here one more time? Any questions on this function? Is this clear? Yes, please. A vertical asymptote means that the function values go to infinity or negative infinity, or either one case, second case, or opposites. So once I'm told that on the left-hand side the limit is negative infinity, x equals 4 must be a vertical asymptote. Better? Okay, other questions here on this function? Okay, good. So I'm looking at this function. I'm asked to find all its asymptotes, vertical, horizontal, whatever, if they exist. So I will start by factoring the numerator, x, and then x squared minus 1. I will continue with the denominator, which is
Negative 6 minus 3x.
So I think of x minus 1, x minus 5.
very good. And then I continue with the top one more time.
It's a difference in signs. So,
Very good. Always remember, you're not allowed to touch the function in any way, shape, or form, do anything to it before you state restrictions. So what I meant to say is you are not allowed to simplify it before you state the restrictions. I can touch it before I state two restrictions, and they are,
X is not existent. Fine.
good. Now I'm allowed to simplify. So the simplified form is this. Okay. The factor that disappeared, which is x equals x minus 1, which is around, it's at the point x equals 1. What will that be? I haven't determined anything, but what will that represent? Will that be a vertical asymptote? Okay, let's say we don't know. We don't know. So let's find the limit as x approaches 1 from the left, and limit as x approaches 1 from the right. Also, limit as x approaches 5 from the left, and limit as x approaches 5 from the right. I have to determine these limits. And then I will identify the vertical asymptotes. Back here for a moment. When the limit on the left is 4 and the limit on the right is 2, it doesn't matter. But they're both different numbers, right? Or even the same number. Can x equals 0 be a vertical asymptote? No, it cannot be. The vertical asymptote requires at least one of the sides to be infinity. If it's both, it's both. But at least one of them has to be infinity for x equals 4 to be a vertical asymptote. So if I get here infinity and infinity, or any sort of combination, infinity, infinity, or negative infinity, negative infinity, what will I conclude about x equals 1? Vertical asymptote. But what if I get a number? What do I conclude? Exactly. So that is going to be the case. If the factor disappears, this will be a whole. If the factor does not disappear, no one can make it go away. It stays in the denominator. It will be a vertical asymptote. Okay, so we have x plus 1 over x minus 5, x plus 1 over x minus 5, x plus 1 over x minus 5, and x plus 1 over x minus 5. So when I plug in 1, what do I get?
2 to the negative 4 to the negative 1.
Exactly. This is not infinity. The other one has to be the same, right? So the other one is also negative 1/2. What do I conclude about the point 1 comma negative 1/2? 1 for x, y negative 1/2. What is this point? Yes. Not vertical asymptote. Because I did not get the infinities. I did not get the infinities left and right. Good. So now let's see what we get when we plug in 5. I have to plug it in first. The top is 5 times 6. So the top is 30 in both cases. What about the denominator? How much is 5 minus 5?
Zero.
Good. So then we know that this is what type of case? Undefined, which means?
Positive, negative.
Exactly. Exactly. So this, for sure, x equals 5, will or will not?
Have a
Will be a vertical asymptote for this function. Yes, very good. So let's figure it out. 5 from the left is 4.9. What will be the sign?
negative.
4.9 minus 5 is a negative number. The top is 30. Now, with 5.1, the top is 30, the bottom is positive, so the answer is infinite. So the problem was asking us to find vertical asymptotes and their limits, and we did find one. The other one is a hole in the graph. And we're also asked to find the horizontal asymptotes, or asymptote, if any. So I'm coming back to the function. Let's write it. Again, I'm going to copy it. You don't have to if you don't want to. I have to copy it. So I have limit as x approaches in. So I go directly to the limit. So x cubed minus x over x squared minus 6x plus 5. What do I have to do next? Plug it in, and I get when x approaches infinity, which of these two is the most powerful term? Good, so then the whole thing goes to? Perfect. So when x approaches infinity, which of these three counts? The other two are too small? Good, so when x approaches infinity, x squared approaches? Good. So clearly I have to do something that I did a few minutes ago. I have to, yes, what is the degree at the top? Good, so I have x cubed. What is the degree at the bottom? So I have x squared. So please tell me what you get.
1
Yes?
minus 1 over x squared.
Perfect?
And 1
Yes?
minus 6 over x plus 5 over x.
Good. I will also simplify here. Where does this go, and this go, and this goes? Where does this entire thing go? 1. But I have x. So this whole thing is x, if you want. As x approaches infinity, this whole thing will approach? Absolutely. So this whole thing approaches 1. This numerator is x. The denominator is 1. So this whole thing approaches infinity. Are they horizontal asymptotes? And remember, we did not really use the fact that it's infinity or negative infinity. We did not use that sign situation. So it doesn't matter if it's infinity or negative infinity. So what is the answer? No horizontal asymptote. I can present the limit as x approaches negative infinity as well. I don't have to do anything to it because I will have an x and that will be negative infinity. Still the same thing. No horizontal asymptote for this function. Anything else? So let's go back to the checklist so we make sure that we covered everything. So you have a problem 24 on page 141 here to solve. We learned how to draw a graph of a function given different conditions. We just did that with problem 9. We learned how to find vertical and horizontal asymptotes. We just did that with this problem a minute ago. And we practiced finding limits of all kinds of functions, and I chose 3 problems. So this is entire section 2.6. Is there anything that you would like to practice with, or can I move on to the last 2 sections? We may finish them today or not.
2-7,
Say it again.
2-7.
7? Okay, I'm going to do 8 first and then 7. And you'll see why. Any questions? Any questions for me? Okay, so 2.7, I'm going to copy both titles, 2.7 and 2.8. These are derivatives and rates of change. But this is a special case of 2.8. If I were to write this book, I would write 2.8 first, and then 2.7.